Welcome to the 2020 Math question 1E. The question tells us that a line is tangent to the parabola y equals x squared at the point a squared, where a is greater than 0. It asks us to find the area of the region bounded by the parabola, the tangent line, and the x-axis. We are given 5 options: a squared over 3, 2a squared over 3, a cubed over 12, 5a cubed over 12, or a to the 4 over 10. Pause the video and try to come up with a sketch of the situation. Okay, let's see if we can make a sketch, and this will be very useful for picturing what we need to do. So your sketch doesn't need to be too detailed, but let's start by drawing some coordinate axes with a on the x-axis and a squared on the y-axis labelled. And then a parabola we know has a upward curving shape, and since it's the parabola y equals x squared, it just needs to go through the origin. That's its only x-intercept. And now we're looking at the point a squared, and we want to draw a tangent line, so a line that just touches the parabola, so that's going to look like this. And the area we've been asked to find is the area bounded by the parabola, the tangent line, and the x-axis. So that's this area in here, which we'll shade with green lines. So now that you know the area which we're trying to find, pause the video and have a go at finding what this area is equal to, and hopefully your answer will be one of these options. Okay, let's begin by trying to find the equation of the tangent line. So how can we do that? Well, the tangent line is defined by having its gradient be equal to the derivative of the curve at the point a squared. So let's start by finding the derivative of the curve y equals x squared. So how do we do that? Well, we differentiate, and since it's a polynomial, we can see the derivative of x squared is 2x, so we just bring that power down. And therefore, what is the gradient at the point a squared, i.e. the gradient of the tangent line? Well, we just evaluate this at the point x equals a. So we see the gradient of the tangent is therefore 2a. So now that we know the gradient of the tangent, how can we find the equation of this tangent? Well, we know its gradient and we know a point which it goes through, which is the point a squared. So we can therefore use the equation of a straight line in order to write down the equation of the tangent as y minus a squared equals 2a times by x minus a. And now we can expand out this bracket, 2a times by x minus a, to see that's equal to 2ax minus 2a squared. And therefore, if we add a squared to y, we see that y is therefore equal to 2ax minus a squared, adding a squared to this right-hand side. So this is the equation of the tangent line. So pause the video here, and with that in mind, try to find the area of this region shaded in green. Okay, let's move on to a new page and try to find the area of that region. Right, so we have our sketch of the situation, and we have the equation of the tangent, and we have our 5 options, one of which will be the area of this green region. So how can we now try to evaluate this area? Well, we know the equation of the tangent line, and we know the equation of the parabola. So how can we find areas from the parabola? Well, we can find the area under the parabola, which will give us this whole area, and we can find that by integrating. But that also includes this area here, so we're going to call that area A, and therefore the green area we want is the area under the parabola, which we can find by integrating, minus A. So the area we want is the integral from 0 to A of y equals x squared, this whole area, minus the part A. So let's begin by trying to find this integral, and we can integrate this as it's a polynomial, so it integrates to a third x cubed, and if we evaluate that at a and subtract what we get when we evaluate it at 0, then we see this is just equal to a cubed over 3. So that's the area of this whole region here. But we now need to find the area A. So indeed, how can we go about doing that? Well, A is actually a right-angled triangle, so if we can find its base length, we know its height, then we can find its area using the formula half base times height. But we know its height is a squared, so we just need to find its base length, which starts here and ends at the point x equals a. So in order to find its base length, we need to find the value of x where the tangent line intercepts the x-axis. So we need to find the x-intercept of the tangent line. We've already found the equation of the tangent, so how can we find the x-intercept of this tangent line? Well, that happens when y is equal to 0. So the x-intercept will be the value of x, which solves the equation 2ax minus a squared equals 0. So moving the a squared onto the other side and dividing through by 2a, we see this is the point x equals a over 2. So we can now add that to our diagram. That's this point here. And therefore we can see the base length is a minus a over 2. So the base length is a over 2. And the height of this triangle is a squared. So therefore our area A is equal to a half times a over 2 times a squared. And we can see if we multiply all these together, we get 8 cubed over 4. So we've said that the green area is equal to this integral minus a, and we found the integral, and we found a. So now if we put these both back into the equation for the area, we see that the area is equal to a cubed over 3 minus a cubed over 4. And we can simplify that to bring everything with a common denominator as a cubed over 12, which we see as option C. So therefore the answer to the question is option C.